Hi, I'm Adolph Oliver, and this is a video clip that covers word problems that have to do with work. Now, there are a whole group of problems like this involve people working together, and here's an example in one of their simplest forms of what they look like. Tom and Jose are painting the exterior of a house. Working alone, Tom can do the entire house in 12 hours, while Jose could do it in 10 hours. How long would it take if they worked together? Well, the interesting thing about this is most everybody who looks at this problem gets it wrong because they think it's simply the average of the times of the two workers together. Well, this would be true if both the workers took the same amount of time to paint the house. But that's not the way it is in this problem. Jose paints faster than Tom, so that means if they start together, when they finish up, Jose will have painted more than half the house. And that's what causes that regular average not to work. It takes a little more effort to get this correct, but we'll show you how to do it. It's not particularly difficult. Okay, let's go back and flesh out the idea here. The key to this is to think about how much each of them does per unit time. And the unit time here is in hours. So we can first say that Tom, who takes a total of 12 hours to do the whole house, okay, what that implies is he does 1/12 each hour. And this is the key. We're going to do the same thing now here when we talk about Jose. Okay, Jose takes a total of 10 hours, and that implies he does 1/10 each hour. Okay, well now, approaching it from that way, we can get the correct answer here, and it's not too difficult. Let's say H equals the hours that they are working together. Okay, so I can take a look at what each of them does. Tom, for instance, gets 1/12 done each hour, and if he's working the H hours, there's the total amount that he does. Okay, likewise, we're going to have him being helped by Jose, so this is added, and Jose does 1/10 each hour, so this is his part. So this is the total amount that Tom will do in H hours, 1/12 times H. Total amount that Jose will do, 1/10 times H. And that equals, of course, how many of these houses they're painting. And since we're only doing one house, we put a 1 here. If it would have been two houses, we'd, put a 2 or half a house, so forth. Well, anyway, we got some fractions to clear here. Now, we don't have to worry about real problems. Real problems have real answers, so there's not going to be any bad ones showing up here. But we find the LCD, which is not hard. 12 times 10, CD would be 120, but the lower one that would work would be 60. So we use that to make our answers a little bit easier to work with. Okay, that being the case, I'm going to multiply each and every term on both sides by 60. I use my standard deal of indicating it by circling it here. Two terms on the left, I hit each of them by 60, one term on the right. Now remember, this guy on the right, even though he doesn't have a fraction, he has to be hit too because this is a balance scale thing. And I normally put a 1 underneath there just to make it look like a fraction, so hopefully you won't forget to do that. Well, the rest of it's not too difficult. 12 goes once here, and it goes 5 times into 60. 10 goes once here, and it goes 6 times into 60. Over here, we didn't have a denominator to reduce, so the full 60 remains. So I go 1 times 5 times h, or 5h, okay, plus 1 times 6 times 8, or 6h, equals 1 times 60, which is 60. Okay, here we go then. I got a total of 11h equals 60. Going to divide both sides by 11 now. And since this is a word problem, we should take that improper fraction and convert it to a mixed number. So the number of hours here equals, let's see, 11 goes into 60 5 times. There's 5 parts left over. So 5 and 5/11 hours. Okay, that's how long it would take the two of them working together. Okay, that's the correct answer. It's not the same as if you just did the old average bit, which is not correct. But to get it correct here is not that difficult. Okay, let's look at some more of these. And we're not always going to have nice whole numbers when you're doing these. You can have regular old decimals. And so we'll be making use of our calculator here to get the final answer. But the idea is the same. Crystal can oil the lanes in a bowling alley in 9.5 hours. So Crystal does it in 9.5 hours, which implies that she gets 1 over 9.5 done each hour. Okay. Now, James, who is going to be helping her out here, if he did it all by himself, it would take 8.2 hours for him to do it. And that means he'd get 1 over 8.2 done each hour. Well, once again, if we take H equal the hours that they're working together, then it's very simple to set up the equation to finish this up. Here we go. We just combine the two parts for each of them. Okay, Crystal here does, let's see, 1 over 9.5 times H. That's, in other words, for the number of hours they work together, you multiply by this, that's how much of it she'll get done. Okay, add to that what James can do, 1 over 8.2 times H. And of course, they're doing one set of bowling alley lanes, so we put a 1. They've been doing 2 sets, we put a 2, or if they did half, a half, so on. Okay, well, now, here's what we're going to do for the LCD on this. Since we're using our calculator here, it doesn't matter if we get the LCD, any common denominator will work. And I'm just going to take the 9.5 times the 8.2. So that's what we'll use for the LCD, 9.5 times 8.2. Just the two denominators multiplied together. Well, okay, 9.5 times 8.2, 9.5 times 8.2, and 9.5 times 8.2. Remember, this guy over here has to be hit also. That's why I like to put a 1 underneath, make them look like a fraction to try and remind you to do it. But multiplying through by an LCD is a balance scale thing, and you have to make sure you hit every term once and only once all the way across. Okay, now let's reduce out the denominators. The 9.5s go here, the 8.2s go here. Last guy, everything remains. Put the leftovers together. 1 times 8.2 equals 8.2 times H. Plus 1 times 9.5 equals 9.5 times H equals, now I'm going to keep these guys indicated. We'll do the calculator a bit all together once at the end. Okay, so there it is, 9.5 and 8.2 times 1. Well, add these together, we get what, 17.7, I think? 17.7H equals, again, I'm still going to leave these guys indicated. Here it is, okay. And now, just divide both sides by 17.7. Okay, and you do that on both sides over here by 17.7 also. We'll get H equal. Now it's time to go get your calculator. And if you take 9.5 times 8.2 and divide it by 17.7, you're going to come out to approximately 4.4 hours. So that's how long it would take for them to work together. So if you have decimal values here, not a particularly difficult thing, just work it the same way. Okay. Here's another one. Let's see, what do we got here? We got whole numbers here. Okay. Matt can harvest a field in 8 hours. Well, we know how this works now. Let's just go right to the equation. Matt does 1/8 each hour, and we use H for hours. Now, by the way, if it was days, you'd use probably D. If it was minutes, you use minutes. But the problems we've had here have all been in hours, so okay. And Sean is going to help. And let's see, it takes 12 hours, so that'd be doing 1/12 times H. And of course, again, we're assuming we're harvesting just one field. If it had been two fields, you put a 2, and so on. Okay, let's see. I think the LCD here is 24, huh? Okay, so now let's turn around and multiply each one of these guys by 24. 24 here, 24 here, and of course, don't forget this guy on the right. Okay, 24 also. It's a balance scale thing. Again, I put a 1 underneath to make it look like a fraction. Okay, reduce the denominators. 8 goes once here, 3 times in 24. 12 goes once here, twice in the 24, and the full 24 stays here. So the rest of it is easy. 3 times h, 3h plus 1 times 2 times h, or 2h, equals 1 times 24, which is 24. I think we got here, what, 5h equals 24. So we divide both sides by 5. There we go. Now, of course, since this is a word problem, we don't want to leave the answer as an improper fraction. We want to make a mixed number out of it because somebody walking down the street has a much better chance of understanding a mixed number value than a improper fraction like this. So we say h equals, let's see, 5 goes into 24 4 times, that's 20, and there's 4 parts left over. So it would take them 4 4/5 hours, okay, to work together to harvest that field. Okay, one last example to look at here. And again, some decimal values, which again, we'll use our calculator, but we can just put it off till right at the tail end. Okay, working alone, it takes Jessica 8.2 hours to mop a warehouse. Well, I can do it, mop the same thing in 10.5 hours. Well, again, we can jump right to the equation. J will get 1 over 8.2 done each hour. And since it's hours, we'll multiply by H. And she gets help from A here, who can do 1 over 10.5 each hour. And in H, and of course, we're assuming we're talking about one warehouse here. So that's where the 1 comes from. Now, once again, for the LCD, I'm simply going to multiply these two denominators together. Not necessarily the LCD, but it may be. But anyway, with a calculator, common denominator will work for us. Okay, so here we go. 8.2 times 10.5. Okay, the second guy. 8.2 times 10.5. And the last guy over here, I'll put a 1 underneath, 8.2 times 10.5. Okay, well, go ahead and reduce out the denominators. 8.2 goes once here and once there. 10.5 goes once here and once there. The last guy, we already had a 1 downstairs, so the full 8.2 and 10.5 remain. Okay, put the leftovers together. 1 times 10.5 times h, 10.5h, plus 1 times 8.2 times h equals 8.2 times 10.5. Again, we'll leave that indicated. What do we got here? I think it's 18.7, isn't it, on this one? Okay, so 18.7. When we combine these two together, h equals, again, leave these guys just indicated for the moment. Okay, now of course, to get the final answer here, what we have to do is divide both sides by the 18.7. Here it comes. Okay, so we get h equal to, and you get your calculator out. Okay, I think that comes out to be about 4.6 hours. So there we go. Okay, so here it is, the work problems. There are all kinds of other fancier versions of these you'll run into in the future. But the basic idea right here, these ones we've been working, are pretty simple to handle.